All right, so let's look at another piecewise function. So this is f of x equals x plus 3 for x less than -1, and then it's x squared for x between -1 and -2. So again, these are two parts, 1 and 2. So it may help to draw a little number line so you can figure out where each part starts and ends. So we got -1 on here. We also have a 2 over here. All right, so for part 1, we do not want to include -1, but we want everything less than that. So that's part 1. The second part, we want to include -1 and go to 2, but we don't want to include 2. And this can help you when you're graphing as well, so you know where open circles are and where closed circles are. Okay, so let's look at the first piece, one piece at a time. This is a linear function. Slope is 1, y-intercept is +3. So y-intercept, let's see, it looks like it happens +3, but what's the x value right here? 0. Is x equals 0 included in part 1 of our function? No, 0 is somewhere over here, so it's not included. So we don't want to graph using x-intercepts, but we could do an XY table, get some points that work, and then draw that line. All right, so let's see, x and x plus 3, and when you're choosing x values, make sure you choose these x values in here. All right, so what about, I'm still going to choose -1, but I'm just going to put an open circle there because I do want to get there but not actually touch it. Let's try x is -1 and x is -2. That's good enough. We just need 2 points to make a line. All right, so -1 plus 3 is 2, and -2 plus 3 is 1. So we got our 2 points. -1 and 2. Again, the function part 1 is not defined at -1, so I'm going to put an open circle right here. And then -2, 1, and then just connect these. And it's just going to go on forever. So that's part 1. Part 2, we do want to include -1 through 2. So let's do, we know it's a parabola, it's x squared, all right, parabola centered at the origin. So let's go ahead and get some points as well, x and x squared. So I'm going to get my key points like -1, which is included, also 2, maybe something in the middle may be helpful. I'll do 0. Since it's a parabola, we want to try to do more than 2 points. Okay, so -1 squared is 1, 2 squared is 4, 0 squared is 0. All right, so now let's graph the second part of our function. Okay, so -1, it's okay to include -1, so we're going to fill in that circle. So -1 goes with 1, so I'm going to put a closed dot right here. 2 goes with 4. Open or closed dot? Well, up here, we need an open dot. Then I'll put my 0, 0, and now I can connect. This is the graph. And so now we actually see why this was an open dot, because if this were closed, we would have 2 points for the same x value. So therefore, this would not even be a function if both of these were closed dots. So these are things you want to keep in mind to make sure you graph something correctly if it's supposed to be a function. All right, so now let's talk about increasing, decreasing, and constant. So we've talked about this before. So remember, when looking at functions on a graph, we read from left to right, just like when you're reading words. And when we talk about function values, we mean values on the x-axis. This is very important. Function values, y equals f of x. We're talking about y values. All right, so in this section we will determine intervals on the x-axis where the function values on the y-axis are increasing, decreasing, or constant. So even though we're looking at y values, we label them using x values because that's the location that it happens. Okay, so we just want to find increasing, decreasing, or constant. All right, so let's start with increasing. So when we read from left to right, we're going down, 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 up, now we're up. All right, so that means we're increasing between 0 and 1. Okay, so in the math world, it's debated. Do we do closed intervals, open intervals? Typically in your homework, it's always going to be open intervals when we talk about increasing, decreasing, or constant. All right, let's continue on. Oh, it looks like a straight line here. We're constant, and then we start increasing again between 2 and infinity. So I'm going to say union, 2 and infinity. So those are all of the places that our function is increasing. Now let's look at where it's decreasing. So where is it going down? Oh, it immediately starts going down. So that's from negative infinity, and then it stops going down at 0. And then, oh, it keeps going up forever or constant, so there's nothing more here. Okay, and then constant, I feel like that's the easiest one to pick out. This is the same function value the whole time, and that's between 1 and 2.